Today we're going to look at energy and efficiency. Efficiency is given by two equations. The first one is that efficiency is given by the useful energy output, so the useful energy that comes out of the system, divided by the total energy input, so the energy that goes into the system. And the unit for efficiency is dimensionless, and that means that there's no unit, because you can see here a joule divided by a joule is just 1. The second equation is that efficiency is given by the useful power output, remember it's a watt for power, divided by the total power input, remember a watt again. So it's the same sort of equation, but just instead of energy, you have power. And just like here, the unit for efficiency, dimensionless, because watt divided by watt, again, is 1. Now, I'm going to show you how we get this equation. So power, a recap on power, is energy transferred in joules divided by the time taken in seconds. Just by its capital letters, P is equal to E divided by T. If I put this equation into here, so rearrange this so that E is the subject of the equation. So multiply both sides by T. You get E is equal to power times time. Sub this into here. So efficiency is equal to useful energy, power times time, output, divided by total power times time for the energy, input. Remember, because energy is in joules. And because the time taken is the same, they cancel. And that is why you have useful power output, because that's what you're left with, divided by total power input, which is your second equation here. Hopefully that makes sense. So I'm going to give you an example / a question. So here you have a wind blower, and it has a battery. Now I want you to pause the video and see what type of energy does the battery store. Okay, hopefully you've unpaused it and you've noted that the type of energy that the battery stores is chemical energy. It can't be kinetic, it won't be potential, it will be chemical because it's a battery just like fuel. It's got chemistry involved with it somewhere. So the battery fuel is energy, the battery fuels energy for the electric motor to work. Now what type of energy is transferred to the leaves? So if you have your battery, which transfers to the electric motor, which causes the leaves to move. Remember what movement energy is. So the question is asking, what type of energy is transferred to the leaves? Pause the video and choose the answer. Okay, hopefully you guys have clicked that it's the kinetic energy. Because as the leaves start to move, that's movement energy and that is kinetic. So to summarize what's going on, you have your battery, which has chemical energy. The chemical energy fuels the energy for the electric motor. So the chemical goes to electrical energy, and then the electrical energy transfers kinetic energy to the leaves to move. So it's kind of a tricky one because it's chemical to electric to kinetic. Hopefully that makes sense. Again though, on the fact of efficiency, a leaf blower is not 100% efficient. How come? Where is it wasted? What is wasted? Well, remember that a leaf blower, if you've ever heard one, it has a lot of what? Click the right answer on the right hand side. Heat, sound or light. Okay, hopefully you've unpaused the video and noted that indeed it is sound because if you've ever heard one, they're just really, really noisy, but also they can get kind of hot, so either or, to be honest. I'm going to leave you with a fun fact. So laptops are 85% more efficient than desktop computers, and you know that what I mean by more efficient is that there's more useful power out of it, or useful energy out of it from the energy / power that's been put into the system. Again, I want you to pause the video, sorry about this, and do this maths question here. If the total power input, so the total power input is 750 watts and the useful power output is 360. What is the efficiency? Remember to give the units. Okay, hopefully you've unpaused the video now and noted that if my total power input is 750 and my total useful power output is 360, I'm going to do 360 divided by 750, right? And that is my efficiency. If you want to give that as a percentage, you can multiply it by 100, so that's 48%. And I gave you sort of a tricky question with give the units. Remember, the unit is dimensionless, so it would be nothing. Hopefully that makes sense. Thank you for watching it. You'll be given, again, one of these photocopied in colour to use as revision or to write your answers wherever you want to write them. Yeah, thank you very much for watching it. Bye!